Classification of images using VGG19. Today we will learn about VGG19 architecture and its implementation. I am Arish Maqsood. If you are looking to start your career as a data scientist from scratch, then you are in the right place. Please subscribe this channel for the latest updates. VGG19 is the convolutional neural network that is trained on more than a million images from ImageNet database. It is an image database consisting of 14 million images organized according to the WordNet hierarchy. This is the intuitive to help researchers, students, and others in the field of image and vision research. This network is consisting of 19 layers deep and can classify images into 1000 object categories such as animals, R objects, etc. As a result, this network has learned rich feature representation for a wide range of images. Here you can see the visual representation of VGG19 architecture. VGG19 is the variant of VGG model, which is in short consisting of 19 layers, 16 convolutional layers, 3 fully connected layers, 5 max pole layers, and 1 softmax layers. There are other variants of VGG like VGG11, VGG16, and others. A fixed size of 224 by 224 RGB image was given as the input to this network, which means that the matrix was the shape of 224 by 224 by 3. The only pre-processing that was done is that they subtracted the mean RGB value from each pixel and computed over the whole training set. It uses the kernel of 3 by 3 size with a stride size of 1 pixel. This enabled them to cover the whole notation of the image. Spatial padding was used to preserve the spatial resolution of the image. Max pooling was performed over a 2 by 2 pixel windows with a stride size of 2. This was followed by the ReLU activation function to introduce non-linearity to make the model classify better and to improve the computational time as the previous models used tanh and sigmoid activation functions. This proved much better than those. And the implementation of 3 fully connected layers from which first 2 were of size 4096 and after a layer of with 1000 channels. And the final layer is the softmax function. So let's move to the implementation part of VGG19 architecture, and here are some important libraries we need to import before starting this project. And here you can see the OpenCV. OpenCV is used for handling the images. It comes very handy in computer vision. And pickle library is used to save the model, and we can reuse that model at any time. We can save our a lot of time as we don't need to train the model again and again. And NumPy and Pandas library is used as a data manipulation tools, and Seaborn and Matplotlib library is used for visualizing the data, the images and graphs, etc. And there are some two important deep learning libraries, Keras and TensorFlow. And the plot model is used to visualize the build model as we will build in a while. And it shows how many layers are used, how many max pooling layers are used, how many convolutional layers are used, and like that. And next one is the VGG19 and early stopping is used to stop the model after our requirement is completed. Like let's say we need to stop our model when our loss is reached at 0.01. And early stopping will stop the training after loss is reached up to 0.01. Okay. And image data generator is used as a data augmentation, and it will regenerate the images by rotating or flipping the data. So main purpose is to increase the data when in case if our data is very low or in size. Okay. And there are some important layers we need to import that we will use in our building the model. And finally, there are some important matrices that we need to import to check our model, like accuracy score, recall score, or precision, etc. So let's run this cell, and we will define our path first. I already separated the data in train, test, and validation folders, and I will do this. Let me copy the path of train folder, and there is a test path. And final one is the validation path. Okay, so let's run this cell. Let me visualize some images from these folders, and for that purpose we need to write some code here. Let's check first train path. Actually, every folder contains three categories like grade 1, grade 2, and grade 3, and that's why we need to connect this folder like that. Here you can see the grade A, grade B, and grade C. Okay, let's see only two images from every folder, as it has many images, thousands of images in every folder. We don't need to show every image here. I need to copy this code here, so it saves our some time, and complete path here. Okay, MP image is used to read the image, and we will show by matplotlib library. So let's run this folder. Oops, here we need to set underscore. Here you can see the image of every folder from train path. Grade A, you can see it has a better quality, and grade B, you can see it has less quality from grade A, and grade C is very lower quality of oranges. Okay, so let's check the test path, and same images are there. So what we are doing here is we are classifying the images based on grades. So these are oranges and we are classifying into grade A, B and C. Let's move further. Here I will define a function that will convert the images into pixel. Let's say we use image array, and we will provide two variables like path and size, and what size we need to convert. Okay, here it will move into the next folder like grade A. Okay, now we will do the processing on every image. So subpath means every folder contains grade A, B, and C, and first it will move. It will look into the train folder. Train folder contains three subfolders like grade A, B, and C, and here we can say that path plus folder name, and then it will move further look into the grade A folder, and grade A folder contains the images. Okay, now we define the image path. Image array, here we use OpenCV function to convert the image into array. Here we will define our size. Image will OpenCV convert into array, and after we will append into data. Okay, now what is this function is doing? It first it will look into the train folder. After that it will move into subfolder like grade A, B and C. Then it will see the how many images are there, and it will convert images into the arrays, and it will append. After converting array, it will append into this data. Okay, we are creating here empty list, and after converting all that images into array, we need to return data. So we need to define our size here like 250 by 250, and for train we need to use image for image array. Here we define our path like train. We can copy that, and we will define, we already define our size here. Okay, let's copy all this for other folders. Let's run this. Here you can see the arrays of all images. Okay, now convert into the NP array. So every image contains from grayscale of 0 to 225. So we need to divide it by 225 to convert to normalize this array. So let's copy that. All right. Now let's see the array. Uh, you can see all numbers are converted into in this range of 0 to 1. Now we will define our variables like grade 1, grade 2 and grade 3. For that we need to define a function. Let's say we can define it as data class, and first we need to say set the variable of path and size, and next one is the class mode. Here we use the image data generator to rescale it. Now we need to define the target size. The size here we will use as a target size. And batch size, let's say 32. You can use whatever you like. And class mode, will be equal to class mode. And return classes. So what this function is doing, this function converts the data into classes like grade A, B and C. And Let's run this folder. Let's run this cell. For train classes, we will use the train path, and size we have already defined, and class mode we are using the sparse. And for let's do the same for test class and validation class. Just change the text here, and here we will use the test path and validation path. So you can see 3150 images for training class, and 901 images for testing, and 460 images for validation. Actually, this data is divided into 70-30, 70% for training and 20% for testing and 10% for validation. I already separated it into train test and validation folders, and let's check the classes. We already defined xtrain, and now we are defining our target variable. This is for y test, and here we will use test class. So this variable contains all the classes of images. Let me show you here. So 0 means grade A, 1 means grade B, and 2 means grade C. Uh, let me show you the indices. Here, grade A for 0, and grade B for 1, and grade C for 2. Okay, let's print the shape of train test data. It is only printing the validation shape only. Now it will print all the shapes of training and testing and validation. Here you can see the this shape is same as for training classes. Like you can see 3150 images and 300 3150 for classes for wide train shape. Okay, next we will move to the VGG19 model, and here we will define the input shape. So we are using 250 by 250 as we already defined by 3, as RGB image contains red, green and blue, so these are colored images, that's why it has 3. And pairs is ImageNet, include top, false. Let's store it in a variable as we need to use it again. So for layer in VGG dot layers, layer dot trainable, okay. Next one is x is equal to flatten. We need to flatten the layers. Here we are using the activation function as softmax. Now we will define the model input and outputs. Our output as prediction. Let me see the problem here. Oh, sorry, I forgot to put s here. It it outputs, not output. So this is the summary of model that our build. Here you can see the convolutional layers. First two convolution layers, next one is max pooling layers, then again there are two convolutional layers, max pooling, then four convolutional layers, next there is again max pooling, four convolutional, next max pooling, four convolutional, and last one we are doing flattening the layers, and last and finally we are using softmax function for three classes. Here we have three classes, so we are using here three, and we are defining here images like 250 by 250 by 3. So next we can visualize this model as plot model. So here you can see the visualization of our graphical view of our model, and next we will define our early stopping, as we don't need to train the model for too much long time. So first we need to define our monitor function, uh, which function it will check. So let's say we need to check validation loss here. We can define, you can use accuracy here too, but I am using here validation loss whenever the validation loss is minimum. Let's see here, whenever you use accuracy, you will set the mode here as maximum, and for validation loss we will set here the mode minimum, and our boss is equal to 1, and patience means 5. Patience means 5 here is, it will see whenever the loss 5 times if repeated the same, it will stop the model here. Okay. Oops, early stopping is not defined. It's very case sensitive. Let's run it again. We need to compile the model. Model.compile. We need to define our loss function here. Loss entropy, and optimizer will be set as Adam. Matrices, accuracy, now we need to fit the model. Extreme and wide train. For validation data, we already defined our validation variables, xval, and we will set the purchase as 10, and next one we should set our callbacks as a early stop. And we need to define here batch size. Let's say 30. and we set the shuffle. Yes, true. Let me see any spell mistake here. No one. Sorry, here we need set it as validation data. So it takes a lot of time for training on this model. Maybe it takes 2 to 3 hours. For this video purpose, I already trained this model, and let me show you here, and you can see. So here you can see the accuracy reaches up to 98%, and validation accuracy reaches up to 85%. And for visualizing this accuracy score, we can plot this graph like this: history dot history, and setting the accuracy versus train accuracy and validation accuracy versus epochs. Here you can see the epochs, and here you can see on y-axis, so you can see the accuracy score of training and validation. Now we can see the we can draw the loss function here, and you can see the loss is minimized as the epochs goes, and then we will we have evaluated our model, and you can see here 81% accuracy and with 0.57 loss function. After that, we use this model to predict the classes using X test data, and here you can see our classification report, and you can see the precision and recall of all the classes, and overall accuracy score is 81%. And finally, you can draw the confusion matrix like of grade A, B, and C, and you can see the confusion matrix of grade A, B, and C versus predicted levels as true levels and true levels. The F1 score and recall score and precision score of predicted versus test. So this is how you can build the VGG19 model, and for more videos, please subscribe this channel, and the I will provide this notebook in the description box. Thank you very much.